Hello, this video is going to be all about hexagons and some other polygons, and we're going to be looking at how we can make something like this. So as you can see, this is running live using Eevee. I'm probably going to split this into two parts because it might take a bit long if I just make it into one video. So the thing that we're going to do in the first part is we're going to take a look at this node, which just creates one hexagon, which is very useful. But what we want is to have a whole bunch of hexagons. Also, we'll look at this octagon node. So if I just change the scale here to 1, you can see it just creates one octagon, and then we can change the width of the octagon, and then by using this we can tile it. Tiling this is much easier than tiling hexagons because here they are all perfectly straight in a perfect grid, while in hexagons the grid is offset at different points. So for now we're just going to be looking at this hexagon node and this octagon node. So first I've prepared something in Desmos to try and show you what we're going to do. So using absolute values, we can make it so that anything we do in this quadrant will get mirrored here and here, because if you take the absolute values, the values are always going to be positive, and in the first quadrant everything is positive. So to create an octagon, what we can do is first get this line, but then only the point right here. So if we take the line going up to here, you can see this purple or pink circle has exactly radius 1. So that line will also have a length of 1. And then we can take every other point in the quadrant and take the dot product of that point with this line, or vector rather. Then what that's gonna give us, like I explained in the other videos, the dot product, the one about vector math, it's gonna give us the length of the projection on this line. So for example, at this point, if you project it, it's always perpendicular projection, and then it's going to give us the distance from the origin at that point. But for all the points that are on this line, the distance is going to be the same, and that's why they will get the same value. However, once we cross, the other thing we'll do is we'll also take the x coordinate, which is the same as taking the dot product with the x-axis, and then we'll compare both of them. So if you look at this line, if a point is here, then it's going to be closer to the x-axis than it is to this line. So all of these will have their x coordinate as the value, while all of these will have their length of the projection onto this one. So if you name this vector v, it's like their v coordinate. And the same thing on the other side. Again, all the things in this region will have the same length, will have a shorter length on this side than on the other side, than on the projection to the y-axis. And that's why if you draw a line perpendicular from anywhere on this line there, they will all have the same value. And this way we can create an octagon, because the same thing will happen in the other quadrants, and we can use the same thing but then to create a hexagon as well. So here the difference is, now our line is not perfectly in the center, because as you can see, this side is longer than this side, but the length of this side of the hexagon is exactly twice as long as this side, because it's a regular polygon. So this one is at an angle of 60 degrees, and in radians that is pi divided by 3. So you'll see me use that. Then the coordinate of this point is the cosine of pi divided by 3, or the cosine of 60 degrees, which is 0.5, 1/2, and the sine, which is square root of 3 divided by 2. So that's how we get the coordinates of this point. Then we just need to take the dot product. And again, if the point is in this region, then it's going to be closer to this line than it is going to be to the x-axis. While if it is on this region, it's going to be closer to the x-axis. And for the points on this side, they are all going to be closer to this line than they are to the x-axis as well. So that way we get a straight line like this, and then so it's like we're flipping around this one. Okay, so let's go into Blender and try and use this method to create a hexagon. I'm going to create a new material because this one is already crowded. So we'll need an input texture coordinates node. Okay, so let's say we have our coordinates. First thing we need to do is split into our x, y, and z components. So our x and y. Then we want to be using the z. And then we need to take the absolute values to mirror the absolute value here. And take the absolute value there. And we move this down. Let's also add in an input value node and set this to be 60 degrees, which is pi divided by 3. We rename 60 degrees, and then we need to take the cosine and the sine. There we go. Sorry. So these will be our x and y components of this vector right here. And now we need to take the dot product. And to take the dot product, you just multiply the x with the x components together and the y components together. So yeah, let's add in a multiply. So this is the x component and this is the x component as well. Let me switch these around. Move this down a bit. And then we need to combine them. We need to add them together. And this is the dot product. So currently this doesn't look like it. Let's use object coordinates. So we have something in the center. Now you can see we get something, but we still haven't. We've just taken the length of every point on this when it's projected onto this vector right here. So we still need to compare it with the x-axis to get our hexagon. So how do we compare? We use a maximum. We take whichever one is greatest. And now you can see we get our hexagon. And if we want, for example, to only show part of the hexagon, we can use something like a less than, and there we go. That's how we create our hexagon. And then we could add in a vector math node set to scale. and then take our original vector right here. And that way we only see part of the thing. So that's how we create the hexagon node. And in the next video I will show you how we can create this hex grid that allows us to... Alright, let me change this to... Well, this is... I don't like Blender system for handling materials. So I'll show you how we can create this.